So the new component here is what we call source utility, G of Z, which captures a preference for and aversion to a specific information source per se, independent of its content. And in wave 2, we're really going to drive down the independence part, okay. What we left out from the original Goleman and Lowenstein paper was the information entropy, because in our experiment, we cannot differentiate, we cannot separately identify instrumental value from entropy. Okay, so the utility function looks like this. So this is the resource you invest to change the information source. Think about the slider, okay? So an agent can incur a cost C of X to increase the probability of getting a set of signals from a favored source by delta P. So my utility, my expected utility is going to be, the likelihood that I receive an article from a favored source and the likelihood that I'm receiving one from an unfavored source and subtracting the cost. So the optimal investment in this case is just going to be delta P, how much I change the probability, and C prime, this is the inverse cost function, the changes in the instrumental value, the changes in valence, and the changes in the source utility, okay. So it's straightforward to have this comparative statics result, which says that ceteris paribus, an agent's willingness to pay to change the information source increases in the information's instrumental value, content valence, and source utility. And we're going to do the decomposition in the experiment. For belief updating, when you read newspaper articles, so that's when sources are open to interpretation. We draw from the theoretical framework of Fryer, Harms, and Jackson. So the idea is, how do we update our beliefs about social issues? It's primarily from reading news articles, from narratives, but narratives are subject to interpretation. When I read the same newspaper article as Charles, for example, we might bring our priors into the article and interpret the same signal differently. So the idea here is that the decision maker will first interpret the signal and then update using the interpreted signal. So the second stage is standard Bayesian updating, but the first stage is new, which is the interpretation stage. Okay, so the setup is from Fryer et al. So you have a true state of the world, you form a prior mu naught, which is the expectation of the true mean based on a normal distribution over potential means with variance, sigma naught squared. Signals are ID according to a normal distribution, and mu t is the posterior of a Bayesian decision maker after observing t signals. So here's the important part, which is the interpreted signal S hat, ST hat, okay. So how do I interpret it? I'm interpreting it basically as a weighted sum of my prior up to that point and the signal itself. And the weight is adjusted by how informative the signal is, okay? And then I'm just going to show that proposition 5, which says that, after a set of t signals, this is your posterior. And if you stare at this, basically it tells us that the estimating equation is going to be a linear function of the prior and the signals, okay? In our setting, it's really easy because they only get 2 signals. They get to read 2 newspaper articles. So t equals 2, and we make a simplifying assumption, which is the signal is as noisy as the prior. So then we plug into this equation. We basically can have a analytical solution to the posterior after reading 2 articles. A Bayesian agent will put weight 2/3 on the prior and 2/9 on the first signal, 1/9 on the second signal. What would a standard Bayesian do in a situation where you have normally distributed prior and signals? A normal Bayesian would put equal weight on the prior and the subsequent signals. So if you have a lot of signal, the prior will be washed out. So comparing these two, it basically gives us 2 hypotheses. One is sticky prior. So prior is weighted more than signals in this case. The second one is an order effect, which is the decision maker. This is, I think, quite novel, okay? So the decision maker will put more weight on the first article compared to the second article. This is something we can estimate because we randomize the order of the articles that we give them, okay? But the other part that you see is that the weight differential is quite small. So now we're going to take a look at the results. How much time do I have? Okay, all right, so I'm just going to, okay, good, thank you. So we're going to go in the order of the prior, information demand, and information processing, okay. So for the prior, I'm just going to focus on unemployment rate because health system ranking basically follow the same order. The way to read it is that the white bar is the conditional on out-group candidate winning, and the dark bar is conditional on in-group candidate winning. And so the way to read it is, what proportion of participants think that unemployment rate will deteriorate if the out-group candidate wins versus if the in-group candidate wins. And how many of them think it's not going to change, and this is the proportion that thinks it will improve. Well, it's going to, a lot more think that it's going to improve if in-group candidate wins compared to out-group candidate wins. So there's a pronounced partisan gap, which is not surprising. We also send it to SSPP, the prediction market out of Berkeley, and the experts there predicted within 1 percentage points of people's prior. The fact that people are divided along partisan lines should not be a surprise, okay? And now we're going to look at the treatment variation, okay, unlabeling. So how does it look? So this is for the information demand stage, here's the slider, okay, so if you're in the labeled condition, you see where the news are coming from. If you're in the treatment, which is the unlabeled condition, everything else remains the same except that you don't see where the article is coming from. Okay, so that's what we call unlabeled. If you're in the information processing stage, again, the control people see the labels and the treatment people don't see the labels, but you see the same article title and the teaser, okay? So what we find for the information demand is here. So here's with labels, this is without labels. This is how much people spend, the money people spend to get information from the relatively more favored source, okay? So with labels, this is out-group versus neutral, okay? So people are willing to spend quite a bit of money, about 15% of their endowment, to avoid out-group information source. For in-group versus neutral, they're actually indifferent. And if you remove the label, you see a decline, quite a bit of decline for out-group information avoidance, and the regression will tell the same story, okay? So I'm going to just summarize this. So in the news domain, when information sources are labeled, participants spend 15% of their endowment to obtain information from a neutral versus an out-group source. So that's information avoidance, and they're indifferent between in-group and neutral information source. This is actually, the second bullet point is like, oh, they're indifferent, but this is good news. The SSPP experts were completely wrong about the second point. They thought they were going to favor in-group information compared to neutral. That was our pre-registered hypotheses as well. The average treatment effect basically says that when you unlabel the information source, it reduces out-group information avoidance by 7.2 percentage points or 50% relative to the control condition, okay? And what does unlabeling do? It partially removes the source utility, okay? That's, if we think back to the theory model. Now let's take a look at information processing. So this is, again, I'm going to look at the unemployment rate. Here's what happens when out-group candidate wins. This is conditional out-group candidate wins. This is conditional in-group candidate wins. The light bar is the prior belief, and the dark bar is the posterior belief. And so two things stands out, or two things should stand out. One is that people are more optimistic when in-group candidate wins. The second one is the prior and posterior are about the same. Okay, so people's beliefs don't seem to move on average. In effect, about 50% of the people don't change their beliefs after reading the news articles. And then the remaining 50%, 25% become more optimistic, the other 25% become more pessimistic. So on average, they washes out. But the fact that there are differences, movements, enables us to actually estimate the model, okay? So this is what the estimation is. This is the estimation of the Fryer, Harms, and Jackson model. So we're basically running posterior on unemployment rate and public health system ranking on their prior and the dummy variable, which is in-group article first, and a constant. So what you see here is no matter what the domain is and who wins, the prior is extremely important, right? Highly significant, and the weight is strong. How about the order effect predicted by the Fryer, Harms, and Jackson? So remember, the order effect says the first article gets weighted more than the second article. And here, there's some suggestive evidence, which is, if you look at the public health system ranking, so first of all, we want a negative coefficient because being ranked number 1 is good. Being ranked number 15 is not so good. So we want them to be ranked lower, so it's negative and it's significant. But once you control for covariates, for demographics, this becomes marginally significant. So let me summarize this. This is the theoretical prediction, right? The prior should be weighed 2/3, and the signals should be weighed 2/9, 1/9. What we get is, first of all, yes, prior belief is extremely important. The estimate varies between 63% to 78%, which is pretty good considering that it's essentially a parameter-free model. The second part about the order effect is that when they read the first article first, they're 2 percentage points more optimistic about the statistics, about the improvement, but it becomes marginally significant. So we have some suggestive evidence for the order effect. The intuition for the order effect is because I'm always bringing my prior into the interpretation of the signal, the earlier signals get interpreted less and end up swaying later posteriors more than a later article. Questions? Okay. So one question is, how did they do? How did they predict? For the easy task, guess which cup is used, the Bayesian updating, simple Bayesian updating task, 67% guessed it correctly. If you're a Bayesian, you would always go with a signal, and the signal is informative 2/3 of the times. So that should not be surprising, except that in our subject pool, 89% actually follow the signal. For the presidential election outcome, 63 predicted correctly. I don't have a benchmark to say, is it good or bad. For the very hard task, for the unemployment rate, our participant, 12% predicted correctly. There was a similar forecast by the panel of US economic experts that was administered out of the University of Chicago, in October 2020, predicting unemployment rate two months out, which is an easier task, and 10% predicted them correctly. So our participant didn't do badly compared to the experts. For the public health system ranking, 7.5% predicted correctly. Okay. So now let me summarize wave 1. So we find partisan gap in prior beliefs. We find for the information demand in the news domain, people by and large show outgroup information avoidance. The unlabeling intervention reduces outgroup information avoidance by about 50%. That's when you reduce source utility. For belief updating, after reading newspaper articles, we find that they have, people in general have sticky priors, and there is a moderate order effect. The unlabeling intervention has no effect on belief updating. I can show you the regressions, but it's just nothing significant. What about the remaining 50%? You can argue that when you unlabel, I can still infer where this article is coming from just by reading the title and the teaser, okay? And so the question is whether we can isolate the effect of instrumental value, content valence, and source utility. The answer is we can't do that in the first wave, but we're going to do that in the second wave, okay? So I'm going to now move to second wave, which was administered after Biden's inauguration. We lost 25% of our participants. So this is a panel, okay, a panel of participants. We recontact them, and we say, we're going to pay you for your prediction of the presidential election and invite you to another set of experiments. We lost 25%. The good news is our sample remains representative of the US adult population in gender, race, and ethnicity, as well as urban versus rural location. And so the objective of the second wave is to dig into the underlying mechanism. So we go back to the information gap theory, and it's all about urns and marbles, so that completely wipe out, unlike newspaper articles, it wipes out the content valence. And our debiasing treatment in this wave is going to equalize the instrumental value of the signals. So what remains is source utility, okay? So the second wave is going to be very similar to the first wave. We started with minimum groups, ask about their political affiliations, and then do bystander allocation among political groups, ask them to update their forecasts, and more specific task for the prior beliefs in the second stage. Then we do an intervention that we call debiasing, okay? So when the participants come back, so we first tell them, basically anchor their beliefs, so we tell them truthfully that across all the participants in wave 1, 67 guessed their cup correctly, okay? Then we elicit their prior about the performance in the neutral domain. So this is eliciting their belief about the instrumental value of different information sources. We say, among Republicans or among Democrats, what's the share of participants who guess the correct cup at the end of wave 1? The result, I'm not going to show you the histogram. Basically, everybody thinks that their in-group is smarter, that they're more likely to guess it correctly. So there are biases, and then that's the basis for our debiasing treatment. So in the debiasing treatment, we tell them, again, correctly, that Democrats and Republicans are equally accurate in guessing the correct cup, which is 67%, and that is identical to the diagnosticity of the marble, which is the neutral signal. And so for information demand, we ask them first, do you want to see a marble or someone else's guess? So again, they have a slider, and they have now 40 cents endowment. They can move the slider to observe a randomly drawn marble themselves, or observe a guess of another participant, and the other participants could be a Democrat or a Republican. If you do nothing, you get each signal with 50% probability, and moving the slider by 10 percentage points costs you 10 cents, okay? Whose guess do you want to see? Again, this is information demand by you seeing the guess of two Democrats, a Democrat and a Republican, and so on. So we reiterate across all these different kinds of compositions. So before showing the result, let me first go through the theoretical framework for part 2. It's a lot easier. Here for information processing, information demand and processing, first, there are only 2 states of the world, so it's a discrete number of states. And the signal is unambiguous, right? They're yellow or green. So here are two states of the world. P is an agent's prior belief. S is the set of signals. And PS of mu is the likelihood of observing S in state mu, and so on. So we're going to use the estimation equation is based on a seminal paper by Dave Grether, 1980. And lots of people reinvented his estimation equation subsequently. So more recently, for instance, the Mobius et al. Also use a similar approach. And so this is basically, we say that your posterior ratio should be the product of your prior ratio times the likelihood ratio. And Grether was the first one to actually raise these to beta and gamma. And so when beta equals gamma equals 1, you're a Bayesian. But you can also incorporate, base rate neglect and lots of behavioral biases endogenously into this model. And our role is essentially to incorporate group affiliation into this model. Okay, so with multiple signals, a Bayesian should pool the signals. You should just count, the number of guesses or the number of marbles that you observe. And so if you generalize it and take the log transformation, it's just going to be a linear equation. And in our case, the prior ratio, because it's 50-50, it drops out. Okay. So with a group structure, so this is group contingent belief updating. With a group structure, a person identified with a subset of individuals as in-group and the remaining as the out-group, then you should basically count the difference in your in-group guesses, out-group guesses, and the number of marbles that you see yourself. So it becomes essentially 3 terms. So this is the number of signals for state A minus the number of signals for state B that I observe with my own eyes, the number of marbles. And this is the difference in in-group guesses. This is the difference in out-group guesses. And so we're basically just going to estimate the beta S, beta I, and beta O. Okay. So for group contingent updating, there's a new theory paper, I think it's still a working paper, by Melman, Deer, and Veldkamp. It's called information resonance. And the idea is that information from your in-group or from people who are close to you resonates more with an individual and therefore receive more weight. So beta I should be more important than beta O in-group versus out-group. And we didn't know about it, and we didn't pre-register the last bullet point, but then we found a working paper after we finished our experiment by Cullen et al. And that, basically they show that actually people weigh their own observations more than identical signals from another person. So this basically suggests that beta S, which is what I observe myself, should be weighed more than beta I, what my in-group guesses suggest. Okay. Again, the last bullet point was not pre-registered. It turned out to be super important in this context. So let's take a look at wave 2 results. For information demand, a marble versus a guess. So what this says is this is the baseline. When you don't correct people's bias beliefs, actually people really want to see a marble themselves. They want to see it more when it's marble versus an outgroup, but they still want to see a marble when it's a marble versus an in-group. But there's a difference here. When you tell them that in-group and out-group and the marble are equally diagnostic, they are exactly the same, what it does is it completely wipes out the demand for seeing a marble yourself versus an in-group guess. It does nothing with out-group information avoidance, okay? Okay, so here's the corresponding regression results. So here you have the debiasing treatment. Yes, it's significant. It doesn't actually do anything about outgroup information avoidance. And so this is something that we did not anticipate. So here's the summary, which is when deciding between a marble versus another person's guess, people spend on average about 7 percentage points or 80% of their endowment to observe a marble when the guess comes from an outgroup versus an in-group. The average treatment effect on debiasing is that it decreased the demand for observing a marble rather than an in-group guess by 7 percentage points. It has no effect on outgroup information avoidance. So which means that now okay, thank you. Now we completely wipe out valence, okay, information, the valence. We equalize the instrumental value. The only thing left is outgroup, is the source utility, and we could not wipe out the source utility, even in such a simple and neutral task. So for information processing, what we see here is here's the probability of observing one, after observing one contradictory guess, when you have three signals, it's optimal to choose. So you have a guess, and then you see two signals, and there's one signal that's contradictory to your guess, and so we look at how likely are people to actually abandon their signal and go with the guess. Here you should not abandon your signal because majority rule says 2 to 1, you should just uphold your signal, go with your signal. But actually a fair number of people abandon their signal, and they're more likely to abandon it when the contradictory guess comes from the in-group, okay? So which means that in-group signals weighs more. When they see two contradictory guesses, again, using majority rule, you should abandon your signal, right? It's 2 to 1, and roughly 2/3 of the people abandon their signal. When they don't abandon it, again, it's weighted more towards the in-group. So this is our bias belief updating estimation equation, which is we're going to run posterior, okay, which is their guess after the signals, after seeing the signals, looking at how much they weigh the marble that they see themselves, the in-group number of guesses, the out-group number of guesses, and the demographic controls. I'm not going to show you the regression table. I'm just going to summarize it because it's a big table. Okay. So what we see here is in a neutral context without content valence, first of all, in-group guess is weighed more than out-group guesses. They put 5%, they basically weigh in-group signals 1/3 more than out-group signals. The second part, which is consistent with Cullen et al., this is something that we didn't anticipate and we didn't register, pre-register, is that they actually put a lot more weight on their own observation compared to the in-group guesses. So they put about 40% more weight on their own signals than in-group guesses. Debiasing has no significant treatment effect, okay, on information processing, which says that the differential weights is actually not associated with any perceived instrumental value of the information source. Okay, so the last bullet point is about heterogeneity. Now remember we did the bystander allocation game. You might wonder, why doesn't she mention it? So it's coming. It turns out that everything that we observe are pretty much driven by the groupie people, okay? So the way we define groupiness, this comes from Crenton et al. 2017, which she used again in her 2020 PNAS paper. So she did this bystander allocation game among minimum groups and also among political groups. And she called, when someone allocates more than 50% to an in-group member, she calls it groupie. The person is groupie. So we're going to use the same definition. Groupiness is defined by allocating more than 50% to an in-group member. Okay. So here's the wave one distribution. What we see here is, they have $6, right? So equal allocation here is 3-3. You give $3 to in-group, so you don't differentiate. Interestingly, there are also some people, like 5% or so, who actually show out-group favoritism. This is not an error. Actually, Sherry and I are doing a meta-analysis of bystander allocation games. It turns out that it's systematic, and it varies according to the relative economic standing, socioeconomic standing of the participants, of in-group and out-group members. Importantly, we have about 37% of our participants who allocate more to their in-group members. These are groupie people, okay. The light bar is the minimum groups. The dark one is, the dark bars are political groups, political bystander allocation games. So these people are groupie, and 60% of our participants are politically groupie. The important part is that they're highly correlated. So 80% of the minimally groupie people are also politically groupie, okay. How does this compare to prior experiments? It's about comparable, it's about a third. So we look at the data from our own experiment from 2009, and then Crenton et al. And Frederica Mengels and a whole host of other people, other colleagues. So this is comparable. So the first version of this paper was actually written all based on political groupiness. And so this version is all based on minimum groupiness, because minimum groups are randomly assigned and they're portable, okay? And this was also based on a comment by Roland Benabou to the first version of the paper. He said, I'll believe you if everything holds for minimum groups. And so now I'm going to present the minimum groupiness. So we call someone groupie if they're minimally groupie, okay? So we want to show that groupiness is highly stable across time. I believe that this is the first panel study of groupiness. So here's wave one. If you look at wave two, when you eyeball the two distributions, they look identical, and they are identical, okay? So 75% keep the same type. And this is wave one versus wave three. So this is wave one, okay. And this is wave three. Wave three has something new, which is, there's a gray bar here. When we presented the experiment design to our lab groups, Steve Leiter said, well, your minimum groupiness is so minimal, and your political groupie was too charged, especially right before the election. So he suggested looking at a natural identity, which is not as extreme as political identity. So we came up with state identity, which is, if you're allocating $6 between someone from your own state and someone from another state. So let's say you're from Michigan, you're allocating $6 between someone from Michigan versus someone from Wisconsin, for example. And the gray bar here is political state groupiness. So I want to make two remarks. One is state groupiness, which is a natural identity, is much closer to minimum groupiness. And when you look at the distribution. And the second one is that there's a sequence of papers by Ben Enke et al. And co-authors. So there's a 2022 management science paper, 2023 restat, and an AER forthcoming paper, which Ben calls moral universalism. And he drops moral in the AER forthcoming paper. I think it's now just called universalist. And I want to clarify that what's called universalist is non-groupie, okay? It's the identical task. It's a bystander allocation game. And if you allocate 50-50, you're a universalist. And then he validated with non-incentivized survey measures. I want to also mention that in his survey measures, he actually restricts people from allocating more to the in-group, to the out-group. And I think that's a unnecessary restriction because they are actually not mistakes. But I just want to clarify, because this came up when I present this paper, which is how does groupiness relate to moral universalism? They're complementary, okay? So moral universalism is non-groupy. So I'm going to skip the regression table and just summarize the heterogeneous treatment effect. So in prior beliefs in wave 1, groupie people are 37% more likely to exhibit a partisan gap, and they tend to overestimate the guess accuracy of the in-group and underestimate the guess accuracy of the out-group. So that's on prior beliefs. On the groupiness in information demand, groupie people have consistently larger out-group information avoidance. How about their response to unlabeling, the unlabeling treatment? If you look at the average treatment effect, it's completely driven by groupie participants. Once you throw in the groupie dummy, it takes away all the effects. For the debiasing treatment, notice that's the response to equalizing the instrumental value of information sources. They're completely driven by non-groupie participants. So groupie people don't respond to differentiation in instrumental value, but they do respond to the source utility. They seem to have, higher source utility. They also reveal a larger in-group bias in information processing in wave 2. So all of these claims are backed by regression analysis. So let me conclude. So what we've done here is to document, how group identity affect belief formation. We document the bias in prior beliefs, information demand, and processing. So we have two sets of interventions. The first intervention reduces the source utility, unlabeled the news sources. It decreases out-group information avoidance, which are completely driven by groupie people. And the second intervention, debiasing, equalizes the instrumental value that decreases the demand for in-group information relative to neutral. They're completely driven by the non-groupie people, or the moral universalists. And so on the measurement front, we're looking at groupiness as a stable trait, very much like risk preferences, that predicts polarization and predicts other economic behavior. For policy implications, there's a custom-made field experiment for this set of experiment. It's published in APSR, the American Political Science Review. So we know that Republicans tend to they're less likely to enroll in the what's called Obamacare, the Affordable Care Act. And so when people do a Google search for health insurance, they randomize them into two platforms. One is the government-run platform, where source utility is very salient, and a privately run platform, which emphasized the market-based nature of the ACA. And they find that Republicans are much more likely to enroll in the privately run website. So this basically says, for policy implications where you anticipate polarization, you should downplay the source salience. And so I'm just going to quickly talk about some ongoing research. I have 2 minutes. 2.5, thank you. So one is a survey paper that's joined with Sherry. We look at groupiness as a predictor of economic behavior. So lots of colleagues have run the bystander allocation game or the other allocation game. So I sent out an email to the ESA announcement list, basically collecting these papers and reanalyze them, but with the idea that we use bystander allocation game as a predictor for their behavior in other decisions, in voting, in dictator games, and so on. So we're preparing this chapter for the handbook, the new handbook of identity economics. And so if you have a publication where you use the bystander allocation games, please send us your paper, your data, your code, if they're available. We would like to incorporate them into this chapter. The other one that's sort of a super fun new project is, asking whether large language models like ChatGPT and Claude 3 exhibit intergroup preferences. So this is joint with my computer scientist, long-term collaborator Qiao Zhumei and Axel Ockenfels, and our student, Jing Yiqiu. The short answer is yes. Not surprisingly, because they're trained on the published results, on the publicly available data, but LLM's decisions have much smaller variance compared to human decisions. So this is, again, I think it's interesting to think about, to what extent LLMs can complement versus substitute human subject research. The last point is another US presidential election is coming up, and so this is, again, an interesting time for an opportunity to look at ways to, economic interventions to decrease political polarization. I'm done, thank you. Yeah.
I wanted to allocate to you the time for discussion, but people, I think, that disagree. So.
Okay, so do I have time for questions?
I'm kidding. Yeah, we have 10, 15 minutes for questions.
I see. Okay. Yeah, John.
Thanks for your talk.
Thank you.
Very careful, as usual. Can I ask about group identity as a model primitive? Okay, is it? You wanted to say it's a kind of preference trait like risk aversion, but could it be a description of other attributes? For example, cognitive ability, linguistic ability. There's the contact hypothesis, which says that exposure to other people reduces this kind of in-group, out-group bias. So could you comment on that, please?
Yes, thank you, John, for that excellent question. So the first question is, whether it's a preference trait like risk, groupiness, which we interpret as sensitivity to group context. It's very hard. People's source utility is actually very hard to wipe out, as you see in wave 2. But I don't rule out the possibility it can be wiped out by whatever information. We did everything that we can think of to wipe out source utility, and groupie people just don't respond to it. And so one question people always ask is, are Republicans more groupie? Actually, Democrats and Republicans are equally groupie. Who are less likely to be groupie? Independents are less likely to be groupie. So in that sense, I think it's an open question whether it's a trait. I'm having sort of one thing that ongoing research which is very different is to look at what is the origin of intergroup preferences. So this is joint work with An Huang from Monash, a graduate student from Monash. We look at ancient irrigation practices. So for places which has decentralized irrigation practices, people tend to treat access to irrigation as an excludable public goods. And you look at intertemporary behavior and where their ancestors are coming from. In the first set of analysis, we find that if your ancestors are coming from areas where there's exclusive decentralized irrigation, you're more likely to be groupie. If they're coming from places where there's either less reliance on irrigation or reliance on centralized irrigation, like the Du River Dam, which is, constructed by the state, you're less likely to be groupie. So this is very much like, time, agricultural origins of time preferences. So there is some historical data which helps us to nail that down. Now, the second the second question about the contact hypotheses, I think people have stereotypes about other people. it's partly preferences, partly beliefs. And what contacts do is it really helps with wiping out any mischaracterizations based on beliefs. How much does it do on the preference front? I don't know. I think the new field experiments looking at contact hypotheses essentially go from the statistical discrimination route, which says that you have more contact with the other part, other group, your stereotype goes down. So it seems to be primarily driven by beliefs. Yeah. Jose, yeah.
Thanks, Anne, for your talk. I was wondering whether you have a measure on how inefficient or how normatively unappealing is this bias, this group information acquisition, whether avoiding non-group or out-group information leads you to inefficient behavior on the health dimension or something that actually costs you in the future?
Yeah. So we can't answer it using data from this experiment because especially wave 1, we don't really have a good measure of efficiency, I guess, unless people have suggestions. But there are lots of other experiments that has been done in the past. I think Tim has worked on Prisoner's Dilemma, and lots of people have worked on, coordination games where you do. So Sherry and I find that in-group matching increases efficiency, and that, again, that we, Roy and I also find it with minimum effort games. But out-group match, when I match with an out-group, it tends to either lead to neutral results compared to a match with a control person or a reduction in efficiency because they don't coordinate as well. Yeah. Yes. Yes, since you have the mic, you get to go first.
Thanks.
Yeah.
Thinking more about the drivers of groupiness, you have an indicator, which is the mug indicator in the guessing, which you use for the most part to guess about another person. But staying with the guess of the same person, you have an indicator of Bayesianness, depending on how you're guessing or not, based on the ball that you extract. If I got it correctly, then you get an indicator of Bayesianness. So some people are
I'm sorry, for easiness or there's
Bayesianness. Some people are Bayesian.
Bayesianness.
Some people are Bayesian,
yeah.
some people are not.
Yeah.
And so I would imagine that people who are Bayesian updaters are less likely to be groupie.
Interesting. So we should definitely look at that.
That heterogeneity component seemed very appealing to me.
Very interesting. We will definitely look at that. That's something that we haven't looked at. Based on wave 1 data, about 89% of the people went with a color. Okay, so which means they're at least consistent with Bayesian updating. But we have 1/3 of the people who are groupie consistently, minimally groupie. The political groupiness is even higher. So. But we should definitely look at Bayesian, Bayesian rationality and groupiness. Yeah. There was a question here.
Yeah, I have a question. Thanks for the talk. Regarding the model, do you have an intuitive explanation why it favors the first information source instead of the most recent information source?
I see. So that's the Fryer et al. Model. Okay. So the Fryer et al. Model has this, sort of unintuitive but interesting prediction of the order effect, which says that earlier signals have more weight on someone's posterior than later signals. And the reason is because you're always carrying your prior when you interpret the signal. It's because of the interpretation stage. So when you encounter the first signal, you use your prior to interpret it, right? Then you update your posterior using both signal and your prior. When you encounter the second signal, you're using your posterior at the end of stage 1, which has incorporated the signal, the first article, into your new prior to interpret the second signal. So the earlier signal has more influence on your posterior because you carried it into the interpretation of later signals. That's the intuition. Good. Okay, and then there was a another question, I think. Or maybe it's the same question. Okay, well, thank you very much. Thanks for the excellent comments. Thank you.
And David Cooper will say a few words in honor of Gary Chen. Thank you both for accepting the invitation.
Thank you. Go ahead.
Okay. So, good morning, everyone. So, thank you, Jan, for your great talk. As you know, Gary has passed away a month ago. It's still hard to believe that he is no longer here, that his Facebook page will remain silent. He was very active on Facebook. And that we will no longer exchange emails as before. So we have lost a friend and a great scientist. Gary had this unique ability to decode human behavior, and this is probably why he wrote so important pieces on social preferences, preferences for efficiency, for competitiveness, or the role of, or the value of commitment through cheap talk communication that can foster trust, cooperation, etc. He had also a very important leading role in the development of behavioral labor economics through his works on optimal contract design, for example. And he wrote also very influential work on behavioral interventions, especially in the domain of health policy. But what I think is more characteristic is his core interest for understanding the sources of efficiency, how to promote efficiency in the society, how to develop beneficial social outcomes through the design of better institutions, from the design of better incentives. So what I would say is that he was very positive, and he was mainly interested in how to improve the life of humans. He had also strong opinions about methodology, and he used to have very provocative and insightful beliefs and convictions about methodology. And so he wrote also very important papers with co-authors on methodological aspects of experimental economics. And I think we value, as experimental economists ourselves, we value the contribution for the profession of these type of papers. What else about Gary? Well, of course, I would say that he was passionate, he was creative, he was boundless. He was a player at heart. So he liked to negotiate, he liked negotiation, he liked intellectual challenges, he liked to persuade others. And I remember that his favorite class was negotiation. He liked to teach negotiation. And he used to, his negotiating abilities very, very frequently. Jan said nice words about that, his ability to negotiate also with editors and trying to convince reviewers. So he was really enjoying negotiating. He was also very quick. You also said that, Jan. He was quick, extremely reactive. So many of us remember that regardless of the location, regardless of the time of the day or the night, for him, he was answering the emails almost immediately. And it was not only that. I mean, he was able to spot very quickly patterns in the data. So he could see patterns in the data very quickly. So he had a good intuition, he was very quick. You know, he started his PhD at the age of 40 or 41, which is quite impressive. And perhaps it has created a kind of sense of urgency. You need to go fast to start a career at this age. And succeeding in the academic career in those conditions, I mean, to do this, you need to be very smart, and you also need to be a very quick thinker. What else? Is support for young people. I think it's important that he liked to interact with the new generation. He liked to help the new generation. He liked to collaborate with them. And I think that there are many young scholars who know what they owe to Gary for that. Well, of course, he possessed a sharp sense of humor. He was often provocative. Sometimes he was excessive. But I think that his friendship was always stronger than his fights. And he had strong fights as well. So today we are sad, of course, because we have lost a friend, we have lost a strong man. But for sure, we will keep in our memory his great papers, his humor, his incredible character, his uniqueness. So Gary, I don't know if you can hear us. If you can, I mean, I'm sorry if we have interrupted your poker game or your softball competition with the Angels. Sorry about that. But what we would like to tell you is that we are so grateful to have a chance to know you, to work with you, and to learn from you. So we miss you, of course.
Thank you. Is this working? So like many people, I knew Gary for a very long time. I was friends with Gary. Like many people, I wrote a paper with Gary. When I was thinking about this, I was trying to think, you know, when did you meet Gary? And I don't actually remember, sometime in the 90s presumably, but I feel like I always knew Gary. And I knew Gary had had some serious health problems, but when I found out that he'd passed away, it came as a complete shock, because I just sort of assumed that Gary would always be there. He was just sort of this force of nature that I thought you could count on, and he was a really good friend. And I want to give you a little bit of a sense of why I think he was such a great scholar, and maybe more of a sense of why I think he was a really good friend. Not why I think he was a really good friend, he was a really good friend. In terms of a scholar, some of the things are kind of shallow. You know, he was prolific, had well over 100 published papers, which is remarkable if you think he didn't start his career when most of us started our careers. He didn't start his PhD until he was in his 40s. He really caught up remarkably fast. He published plenty of papers in top journals as well. It would have been an admirable publication record if he had started with his PhD in the 20s. To have started as late as he did and achieved this is really quite remarkable. He also had tremendous impact. The easiest way to see that is just to look at the citation counts and see how high they were. If you look at Google citations, he's well in excess of 30,000 citations. And he wrote some really important papers. And when you look at them, you can sort of see why he was such a good experimental economist. And his interests were very diverse. So a lot of us tend to do a certain sort of thing, and we just do it again, and we're good at it. And that wasn't actually true of Gary. So his best-known papers were probably theory-oriented papers. So Charnas and Rabin is easily his best-known paper. It's a remarkable paper, well worth going back and reading. It deserves all of its credit. And what makes it so nice is it brings together some really interesting theory. Read the appendices. The appendices are actually better than the main paper, really seriously taking psychological game theory and incorporating this into the model. And at the same time, some very interesting things in terms of the experiments. Just this idea that you can use these fairly simple choice experiments to try to pin down what people's preferences are. That may seem like a commonplace idea now, but it wasn't a commonplace idea. It was a really clever design thing. And this was typical of Gary's papers. When he worked with more theory-oriented authors, he took the theory quite seriously. He thought carefully about how can you actually test this theory, but he also had a knack for elegant design. So if you think of Promises and Partnerships, his paper with Martin Duffenberg, which is maybe his second best known paper, it's another example of this sort of thing. You know, The theory is simple but very elegant. By chance, it again draws on psychological game theory. The experimental design is not a complicated design. The data analysis, Gary was never, and I know this from having worked with him, a fan of complicated econometric analysis. It's simple, but the design is really clever, and clever in a way that lets you get at sort of the heart of what it is that the theory is telling you and how that translates in how do people make decisions. If he had never done anything other than theory-oriented experiments, he still would have been very successful, but he did lots of other things. And that's kind of what made him, in some ways, unique. He ran lots of field experiments. His field experiment on exercise and econometric is a fantastic paper, really important field experiment. He wrote lots of papers on methodology. I haven't come even close to covering everything that he did. He did very important work on risk preferences and gender. He did very important work on group identity. He just was voraciously interested in economics and willing to study lots of things. The other thing that, if you look at his record, really stands out is he was very broad in terms of who he worked with. He was not somebody who said, I have this group of people, they're my people, and these are the only people I write papers with. He's willing to write with a lot of people. He wrote with some very big stars, so Rabin, Jackson, so on and so forth. But he wrote with lots of younger people who weren't very well known and wrote really good papers with them. That he was not somebody who thought, I can only write with, the creme de la creme. And it was one of the defining features of his career that he was willing to so broadly work on this. As a friend, I spent some time trying to think about why I liked seeing Gary so much, seeing him at conferences. Occasionally, we didn't actually talk on the phone much. We tended to text back and forth a lot. So why it was always so much fun to communicate with him. The guy was just incredibly smart. And it was just nice to talk to somebody who's like, academia is full of people who are smart, but there's smart and there's really smart, and Gary was really, really smart. And he was interesting. And part of what made him interesting was he was very opinionated and he was very frank about his opinions. A lot of times they weren't what you expected. A lot of times they were very insightful on methodology. And just the other day, there was a methodology problem on a paper I was reviewing. I said, oh, that's like a natural, I can't email Gary and ask him what he thinks because he's not here anymore. It seems strange to not be able to email Gary. But you could always count on him to have an opinion, and you could always count on his opinion to be interesting. You might not agree with it. And there are certainly things on which I did not agree with Gary, but it would always be interesting, and it was always just sort of fun to talk to him because it wouldn't be sort of this blah, he had nothing to say, it was all very bland. He came and he always had something interesting to say. Another word I associate with him was indomitable. He did not have an easy start to his career. Starting your PhD in your 40s is not the typical thing to do. And in terms of getting his first job, it was really a rough go of it. He spent some time in Spain. He spent some time in visiting and postdoc type of positions. I remember there was one point I was talking to him and it really looked like he was going to end up at the University of Nebraska, but not the main branch, one of the subsidiary branches. That didn't happen. He ended at UCSB and spent the rest of his career there. It really took a lot of toughness to push through and get through what he did at the beginning of his career and to be as successful as. And this sort of toughness and willing to push through shone through. He was always willing to advocate for his papers. He was always willing to advocate for opinions that he felt. He was always willing to advocate for people if he felt that they needed to be supported. And this was sort of a very strong characteristic of him. He was a generous person. This shows, he was willing to talk to everybody and give time to everybody. Not everybody is willing to do that. He was a genuinely funny guy. He sort of had a good sense of humor. He was a very non-conventional person. If you ever saw one of his talks, you would have realized how non-conventional he was. He had a sort of a set of corny jokes that he liked to tell during his talks. That was very Gary. One last word that I have here that Marie-Claire used as well, he was a very passionate guy. In the end, maybe that was the most defining feature. When Gary felt something, he felt it very, very strongly. When he wanted to do something, he was very committed to it. And in terms of both why he was so successful as a scholar and why he was just a great person to be around, I think more than anything, that was it. That he grabbed onto things and grabbed onto life and really just put tremendous energy into it. And it was always just fun to be around him and see what was going to happen next. So thank you. And Gary, wherever you are, my guess is, Gary's not in heaven or hell. He's busy arguing this.